Okay, so first let's review all of our rules for exponents before we start working on the specific problems. So if I have x squared times x squared, then the rule here is that I'm going to add my exponents. So that's x to the fourth. That's the shortcut. And I made another video about this if you want more detail, but this is just like a quick run through. If we have x squared to the third power, then here we multiply the exponents. So x to the 2 times 3 is x to the 6th. If we have 3x squared, then everything in the parentheses gets squared. So this is 3 squared x squared, which is 9x squared. If we are dividing, it's the same idea. So if I have x over 3 squared, then everything in here is going to get squared. So this is x squared divided by 3 squared, or x squared over 9. So looking at the problems, if we take number 11, we have 10y to the negative third power. Well, that is 10 to the negative third and y to the negative third. When we raise something to a negative power, it's like instead of multiplying, we're dividing. We're doing the opposite. So this is 1 divided by 10 to the third. So now we've gotten rid of the negative. And 1 divided by y to the third. So again, we've gotten rid of that negative exponent by flipping it to the bottom. So this is 1 over 10 to the third, y to the third. And you can leave it like this, or you could do 10 to the third power, which would be y to the third. Okay, and then like number 12 here, we have 4 over n, that's all negative, to the 5th power. So thinking about the negative, if we have 5 negatives all multiplied, these two make a positive, these two make a positive, but we still have this one left over. So the general rule is that when you're multiplying lots of negatives, if you have an even number, it's going to end up being positive, and if you have an odd number, because you always end up with this leftover one, it's going to stay negative. So this is negative 4 to the 5th power over n to the 5th power. So each of these pieces gets the 5th power. The negative sign gets the 5th power, but in the end that just stays negative. Number 13, this is 1 over 2k squared to the 5th. So 1 to the 5th over 2 to the 5th times k squared to the 5th. So that's 2 times 5, or 10. Right? I have k squared, and then I have 5 of those, so total there's 10 k's all being multiplied together. 1 to the 5th power is just 1. 2 to the 5th power, 2, 4, 8, 16, 32, k to the 10th. (14) 6c over 7 to the negative 2. Oh shoot, I just realized that wasn't on the screen. See, this is why I miss being in class. If that happens in class, you yell at me. But there's nobody to say, hey, Withy, get back on the screen. Okay. Let's go over this again. So we have the negative 1, 2, 3, 4, 5 negatives. Stays negative. 4 to the 5th power, n to the 5th power. Here, 1 to the 5th, 2 to the 5th, k squared to the 5th. 2 times 5 is 10. 2 to the 5th is 32. K to the 10th. Okay. All right. For this one, we have everything is to a negative power. There's lots of different ways that you can deal with that, but my favorite way, or my preferred way, is to deal with the negative first, and you can do that by just flipping the whole fraction. So this is now 7 over 6c to the positive 2. So negative says flip it, so I flipped it, but I keep the 2. And so now I have 7 squared over 6 squared times c squared. And before I go off again, this equals 49 over 36c squared. Sorry, my computer froze, so I can't see the next problems you sent. All right. Okay, so then going on to scientific notation. Let's get back on the screen. So scientific notation says that when we have really big or really small numbers, we write them as in a different way so that it makes it easier to look at. So if I had 1, 5, 6, 2, 8, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, that's a really long number to deal with. And so I'm going to rewrite this in scientific notation. So how this works is we take the first number and then we put a decimal after it. So we should only have one digit before the decimal, whatever that number is, but just one space before the decimal with a number in it. And then we're going to have 5, 6, 2, 8. I'm going to write the rest of these numbers. And then once I get to the zeros, I'm not going to write anymore. So I'm just going to write this. And then times 10. So how many times would I have to multiply this by 10 to get back to this number? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh. Okay. So 1.5628 times 10 to the 15th power would get me back to this big long number. So this is just a little easier to read. So then if I am working with numbers in scientific notation, like in the example here, we have 1.25 times 10 to the 8th divided by 6.25 times 10 to the negative 4. So now I'm taking this number, these numbers that are written in scientific notation, and I'm dividing them. Well, to do that, I'm going to divide this part and divide this part separately. So first I'm going to take my calculator. If it ever loads. And I'm going to divide. Remember, when we're dividing, it's always the top number divided by the bottom number. There we go. So 1.25 divided by 6.25. So I've got 0.2. So this part is 0.2, and then I'm just going to bring down that times. And then I've got 10 to the 8th divided by 10 to the negative 4th. Well, this is just like my exponents. So I'm going to keep the base and subtract the exponents. 8 minus negative 4. So 0.2 times 10, 8 minus negative 4, minus a negative. Those two negatives undo each other, right? Because it's the opposite of negative 4, so positive 4. So this is a 12th. Sorry, I'm off the screen again. All right, and then I want to move this to be in scientific notation again. So this is 2.0, or just 2, times... If I moved this this way, then I need to adjust this. So this is now 10 to the 11th, because I've taken one of those 10s. I said 0.2 times 10 is 2. So I've already used one of these 10s to get from here to here. So I've got 11 left. All right. And then going through the next page. Sorry, this video is getting kind of long, but that's okay. Let's see. This is just kind of putting it all together. So we have to remember that anything to the 0 power is going to be 1. That's from our exponent rules. And when we have 5 to the negative 4, that's going to be 1 divided by 5 to the 4. If this were 5 squared, I'd say write it as 25, but with a number like this, just leave it in exponential form. Let's see, 2 to the negative 4. I am way off the screen again. I am just not doing well. There we go. 2 to the negative 4 divided by 4 to the 0. Remember, anything with the negative is going to move down. So now I have 1 over 2 to the positive 4. When you move it, you get rid of the negative, times 4 to the 0 is 1. So then this is just 1 over 2 to the 4th, or 1 over 16. Either one of those will work. Alright, I think I'm going to end the video there.